Just wanted to say thank you very much for having us here. This is obviously the first time CSE's really done anything in public, so bear with us. This is our first time. Just to introduce myself really quickly, and if you can't hear me in the back, just throw something at me. I have a habit of talking really, really fast, so I'm going to try to really slow down. I might have to drink some more just to kind of help me out here. My name is John O'Brien. I am currently a senior technical advisor within the communication security establishment within the cyber defense operations branch. Our focus is primarily on malware analysis and automation. My background is as a computer science developer from the University of New Brunswick. I came out of school doing operations, administration, development, and kind of got thrown into this world of reverse engineering. I actually volunteered to do it back before there was actually any books or guides or anything like that. And then I spent the next 6 years smashing my face against a monitor. It's actually really fun now. There's tools to help you. Yeah, I'll leave it at that.
Bonjour, moi je m'appelle Steve Garon. This is only the only bit in French, but if you have questions in French afterwards, you can do it. Je suis le développeur principal pour AssemblyLine à CSE. I was in school at University of Sherbrooke, and I joined CSE about 11 years ago in the malware analysis team with John O'Brien. And then since the last 7 years, I've been working on the AssemblyLine project.
Steve was one of those ones that started off doing reverse engineering and realized it actually wasn't any fun and then just stopped. He went back to developing because that's way more fun. You just get to build things all the time. So generally speaking, when we come out to these recruiting events, people always come up and they ask us who we are. And I thought it'd be more fun to actually talk about who we aren't because that's how I roll. So if any of you have read the CBC article last week when we actually released AssemblyLine, the heading of the title was Canada's super secret spy agency releases some tools. That was actually quoted from my ADM, who said that sarcastically because we don't really take ourselves too seriously. And there's a lot of kind of conspiracy stuff that kind of goes on along. Unfortunately, when you say something to journalists, they generally speaking quote you and put you in, and it was really good fodder. So we are not a super secret spy agency. We have a website. We are here. We have our pictures on the web. We're out. Another thing that people like to ask us, and if you come into our booth and ask us if we're CSIS, then I'm not going to hire you. I'm just going to tell you that right now. We are definitely not CSIS. And after writing this and reading this, I kind of realized that this actually made CSIS look really bad. They're actually not that bad as much as the media likes to make them out to be. So if you're interested in that type of stuff, by all means, go have a chat with them the next time you see them at a recruiting fair. So who are we? We are Government of Canada's lead security agency. We are also the lead cryptological agency, the lead intelligence agency. We have 3 mandates. And I've actually only put one of them up here because the other ones tend to get really fuzzy. But the teams that we work on is the IT security branch within the Government of Canada. And our job is to provide advice, guidance, and services to help ensure blah, 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 blah. We defend the Government of Canada. That's our job. We are the last line of defense against all the bad things that are happening in Canada. We don't have the option of failing, right? When we fail, bad things happen. Other countries, other criminal organizations, they get some intelligence, they get some intellectual property, they steal our money. It's a bad thing, right? You want us to succeed. Failure is not an option for us. The other mandates that we do have is we do provide foreign signals intelligence for the Government of Canada. And I know that tends to be where people get, the tinfoil hats on. You have to remember that this is all things that the Government of Canada is asking our organization to do. This is all within the law. If you don't like these things, then talk to your MPs. Right? You can't just complain about it in Reddit as much as everyone loves to do that. The third mandate is that we provide technical and operational support to military and law enforcement within the country and abroad. We have the ability to make a real impact on real life events. So this is a very technical audience. Everyone kind of understands the state of affairs right now with all the bad things that are going on. But we felt that just throwing a funny quote up here would be pretty good. So this is a quote from 2002, the White House cybersecurity advisor, basically saying that if you worry more about what type of coffee that you're providing your employees than you do about what you're actually doing to secure your network, there's a problem, right? And I would argue that we're still in this state. 15 years later, people still don't get it. If you can't not protect your stuff. If you have any shiny toy, it's like kindergarten. If you have a shiny toy, someone is going to come and try to take it, right? Whether you're a startup company or a multinational company, you have to realize that you have to protect these things, right? if your grandparents, your parents, like they have family photos on their computer, right? It's the internet is a very evil place right now. Ransomware just kind of changed the game. It used to be fun, it's this kind of cat and mouse game. Everyone had this like thieves honor, and now it's just evil, right? They're gonna kill your cat videos, right? What are you gonna do if you can't get your cat videos anymore, right? That's terrifying to me. What do I do? So I'm going to try to not talk about CSE anymore. I'm going to go back to what AssemblyLine actually is. So going back about, say, 7 years, Steve and I were on a team doing incident response for essentially the entire government of Canada. We had a fairly large analytical team, and then only 2 people that actually really understood what malware was. So everything kind of came to us, and we're developers by heart, so we're lazy. So we decided that rather than doing things manually over and over and over again, repetitively, we would just build something that would automate ourselves out of a job. Right. So the core mission statement here was to have a consistent analysis and reporting for malware. Right. On a daily basis, we'd be getting maybe 10 suspicious files, 5 of which were probably unique, 5 of which were probably Internet Explorer, because this was during the time of browser helper objects. And our analysts didn't really seem to understand the difference between Internet Explorer and something that was bad. It's just, people were learning that. And on a given day, depending on whether or not Steve and I were in or were sick or whatever, there'd be between 0 and 5 files that were actually analyzed. So that was a problem for us. So we decided we're just going to automate it. So for those of you who've probably seen XKCD a couple of times, this is always a good idea when you start, right? So I spend a lot of time on this task. Let's just automate it, right? That'll make things way better. And the top picture here is basically the theories that you write some code and it takes a little bit of time, and then automation kicks in, and then you have all this free time. You can go browse some more cat videos. In reality, you write some code, it doesn't work, you debug it, it doesn't work again, you change your mind, you rewrite it again, and then you just keep having this long tail of development. And I'd like to say that wasn't the case and that we actually solved all the problems, but we didn't. We actually just, we solved our problem, but we had this problem, and we had the more problem with, we actually found more malware. Whoops. There's a lot of bad things out there, apparently. So, as in any great development project, especially within the government, scope creep likes to set in. And someone had the brilliant idea of, well, let's just take this thing that's it's been used for 10 analysts, and let's just plug it into the internet and just detect everything. Right? And when I say the internet, I don't mean the internet. We're not going out and spying on the internet. That doesn't happen. For us, for the cyber defense teams, the internet is essentially an aggregated pipe of all the traffic going into the government of Canada. So emails, network traffic, any way that someone could attack an employee within the government of Canada. That's the system that we have to defend. So obviously that's more than 10 files. Just a few more than 10 files, right? So from 10 files to 10 million, like this is fine, right? We can handle this. We're awesome developers, we'll just wave our scale one. We'll buy a cloud. We don't have any clouds. We have air gap networks where we have to do these things. So obviously, the thing burst into flames several times. We rewrote it a couple of times. It kept on bursting into flames until it got to the point where it was kind of good enough. Like we'd come in the morning, and whoever was the first one to come in the morning, they would check the system to see how many things were on fire. And we kind of got tired of doing that, right? So we said, like, let's try this. Let's try this again. So we brought in a couple of new developers, and we said, all right, like you guys are going to solve this. We're going to draw you a whiteboard picture. That's it. That was our requirements document, our business case. It's just a whiteboard. We didn't touch it for like a long time. And kind of the core aspects of this system that we had, given that we had 5 orders of magnitude increase in files, so we needed to distribute this. It couldn't be on a single box, a couple of boxes. You had to be able to have a cluster. It had to be able to handle unbalanced workloads, which seems a bit odd, but when you think about the internet, it's never stable, right? There's cat videos at 10 o'clock in the morning, then there's real work in the afternoon, and the files just are all over the place, right? So if we didn't have the ability to scale these things, it wouldn't work. As well, because we like to run off the oldest hardware possible. Like we'll take a toaster and use it if we can. I'm really cheap. We had to be able to recover from failures because again, we've had to spend a couple of years where everything broke all the time. As well, because the internet is just redundant. We had the need to have aggressive deduplication across the entire stack, and as well because we had analysts that knew where we sat. We had to have an alerting system with workflow management so that they wouldn't come and harass us if we told them there were too many things that were bad. And at the end of the day, it had to scale, right? So we did that. And this is where we are now. So we, on a daily basis, we ingest about 10 million files, and that can fluctuate depending on how many people are on the internet. We actually are able to deduplicate based on things we've scanned in the previous day or two down to 2 million files per day. And then on that same 24-hour period, we're generating between 3,000 and 150,000 alerts. And those are, generally speaking, pretty malicious. I was joking, actually, that technically it's between 0 and 150,000 alerts, because, again, things break sometimes, but we won't talk about that. It just works. It always works. So going to go to a really 10,000-foot view, because, again, the question people always ask is, what is AssemblyLine? We actually have a hard time describing it because we have, a few people on our team. Everyone describes it somewhat differently. So this is literally the simplest way I can describe it. Someone or something gives you a file. You take that file and you put it into our API or through our UI, depending on how much you hate our UI. And then the system itself distributes that file out to a specific set of services in a specific set of order that you configure. Any files that are extracted while you're processing are resubmitted back up for further processing. So you have that nested hierarchy, which a lot of other systems don't quite have. And at the end of the day, each service is independent. It generates its own score of maliciousness. It can generate tags, which you can think of them as attributes or features. And then it has the ability to generate a text-based result. So really, that's the simplest view of that the system. So disclaimer: malware is bad. Okay. I don't feel that I have to explain this, but I've been told that I have to. So the system is designed to process malware. You have to segregate this from your whatever corporate network you have. You have to assume that anything within the system is going to blow up and just burst into flames and try to kill you at any given time. So put it somewhere without any sharp objects. You need to HTTPS in for the UI, SSH in to admin. That's it. You will most likely want to run services that will actually execute the malware. You're going to run it into Cuckoo or to dynamic processing or to unpack it. So be aware. We've built in the ability to have services that can run binaries, that can run as containers, or that can run as VMs, depending on how much you trust that service. Choose where it goes. Going into the VMs obviously takes up more compute, so your mileage may vary. And then the one other thing I'll talk about, because we don't really talk about this at all, is that any files you download out of the system are inerted, and we have a little file format called cart, which we can talk about after the session. It's because we run this on a corporate classified system, our IT security get really mad if we download malware. We like to make them happy. So another question we've been getting lately is where do you actually put this, right? Kind of define it here as your network, the things that you trust, and then that thing over there on the right is the thing you don't trust. In our case, data sources are inbound emails to the government of Canada, files that are downloaded off the internet, files that AVs might pick up locally off the machines, and then as well analysts. Analysts are really good at finding things, and it's our job to make them go away. So if we can give them enough information that they're happy, then we're all solved. One piece that's not on here is what you can do with the assembly line. So if you want to, by default, this doesn't really do anything. It just has an in and out. That's it. The out realistically can be tied into any automated defensive systems you have. So if you have firewalls, DNS blocking things, you can very easily plug those into it. And we do. It's the data that goes through assembly line within our production system is being used to automatically defend the government of Canada. We take those 150,000 alerts and we actually stop the bad people. This is a very high-level overview of kind of how the system's plugging together, because Steve didn't really want to go into it. On the top corner, UI API. I'm not sure if anyone can read that. All of our ingest stuff goes into a process what we call Middleman, and all it really does is it does deduplication, prioritization, whitelisting. It's basically its job is to not scan, right? So if it cannot scan it because it's seen it before, or because it doesn't really care, it will. And then it fires that off to our dispatching layer. Dispatching layer is basically their job is to make sure things finish, or that they fail enough times that we don't really care and it'll just let it go. And then all the way on the right, we just have our services, and those are plugged into Redis and Riak. And really, if you were to draw the actual connection lines in this, there would be lines from everything to everything. So just pretend like this is what it actually looks like. The one interesting thing about this is that we can add in, another 100 service A's, and it'll just scale. We don't have to have this fixed topology, which is a lot of other streaming processing systems have, because again, they assume a balanced workload. They assume the services will all take the same amount of time. That's not valid in our use case. And I'm going to done talking now. So Steve, take it over.
That's my turn. All right. So let's actually dive into this. So John was talking about the actual the actual design of the system and the pieces. So I'll jump into our dashboard, which actually checks the health of our system. So here you have the middleman where it ingests all the files. It will drop the files into different queues, which are critical, high, medium, and low. And then it will feed then dispatcher to be able to feed those services that are on the bottom. You can see here it's red because we don't have files that are coming in the system. That's pretty bad for us. So if we don't have files coming in, we have to know that it's going on like that. So dispatcher here, it's responsible to send those jobs that it receives and dispatch to the services, so the services get their job done and they respond to it, and then we can actually say, okay, it's done, complete the submission. And then you've got the whole list of services that we have right now here. One card per service, and then you see here there's a number of worker running. So we have one running out of one, so we've provisioned one worker for this specific service on the specific cluster. I'm talking about provisioning. This is extremely easy to adjust the load on your server. So we have a provisioning page that displays the number of core total to your cluster. Obviously here it's not a lot, it's just a dev VM, so there's 2 core, and then we have 8 gigs of RAM for that cluster. If I load the current config, I can see that I'm 500% over provisioned, so that's not going to play out that well. But basically what I can do is I can actually adjust for any service how many instances of that service I want to run on this box. And then when I have something under the actual load, I can just go at the bottom and say, okay, I'm going to test this. It's going to distribute the number of services into the cluster, and it's going to create me a plan. And after that, it saves profiles into each of those machines. And when they restart, they'll load that profile, load the amount of services, and they'll be ready to process. So, and there's one more thing on this thing is we have a flex node that we call. So instead of provisioning all your nodes, you can actually set one to be flexed or many to be flexed. And what they'll do is they won't load a profile at startup. They'll just look at the queues of every given service, and they'll find the service that's the busiest and spin up as much as they can workers for that service so they can actually lower the queue for that service. And then you can go to our host page, and then you see all the machines that we have right now in the cluster. You can split the card and say, okay, restart the node, and it will apply the profiles. So you can actually rebalance your cluster or changes the number of services you have for each services on the fly, and it will just work, and it will keep processing, and there's no interruption. So enough about the infrastructure. Let's actually submit something to AssemblyLine. So this is the main page. When you land to AssemblyLine, you get to that page. First off, I'll have you look at the slider here. So you can, yes, put a file in, but there's a lot of configuration that you can put to your scan to change the behavior of your scan. So you can actually set the priority. Every single queue in our system is a priority queue. So you could say, okay, my scan that I need right now, I need the results now. I can't wait for the 100 million things in the queue. So I want to set it to high priority. It's going to jump in front of everyone, and it will get processed faster. Also, our system is not a TKB. Therefore, we can't keep the data forever. It's an in-out system. So you put the data in, you get a result, you keep it for a few days, and then you delete the data. So it's if you want to keep that data, you need to take it out of the system. So we have a time to live in days for each scans of in our system. Here it's 15 days. After 15 days, it will be deleted. Also, each of the services can have specific parameters. For example, I have a password protected zip, and the password is not in the default list that we try when we try to decompress zips. You can put the password in, and then when we do the submission, it will just use that password to unzip the zip. And then last but not least, the service selection. So you can actually select which service you want to use during that scan. So you can select them all, or you can just take off some types of services, actually select specific services, and it's all up to you. For now, we'll just use all. So if I add a file in, demo zip file, here you go, start scanning. So I have a demo zip with 4 files in it, and it's done. So it took 3 seconds. That's not really true, because what we do is we do intensive caching. So because that file, I scanned it over and over in the system, it's already in a cache. The service have not changed. It's the same file. So with the service version and the file hash, we decided, okay, we've seen that file before. We've already produced the results. Therefore, we're going to serve you the same result as before. So we do extensive caching. And that's one of the ways that we actually cope up with those 10 million files. If you take a look at the submission information, that's where you see everything that you've selected during your submission on that left pane that I've shown you, with the password to go to extract and everything. The metadata section is if you do send your file through ingest, you can actually set metadata to keep with your file, and you'll be able to reference that metadata back to see, okay, where that file come from. Because, I mean, we have tons and tons of millions of files, so we need to know where they come from. Then you got an executive summary. What that is basically during the system processing, we extract features off the files, which we call tags. Tags have a type and a value. So, for example, here we have implant name, and then we have two implant, Dooku and iBanking. So basically, we've extracted those properties, and then in the executive summary, we're bringing up properties that are important, so the analyst can make a decision on what file to analyze and everything. So for example, I have the list of files here that was extracted during the run. If I click on iBanking, I can say, okay, it's this file here that was identified as iBanking. For Dooku, it's this file here. So let's dive into this one. And then when you click on a file, you can view any specific information about that file, like hashes and size and SSD, the type of file that we've identified for that file. You have the file frequency, which is, okay, when did we see it first? When did we see it last? How many times? The submission summary, who submitted that files, how many times? And then the exhaustive list of generated tags for this file. So these are all the properties that we've extracted for that file. You will see that the Dooku is still selected. So I could drill down and see, okay, which service identified this file as Dooku? So it's Yara. If I open it, you can see here we have a rule to one of the Dooku samples, and it identified this one as an implant. So you can actually say, okay, well, what else do we have on Dooku? If I click the little search thing beside the tag, it brings you to the search engine. Everything in our system is fully indexed. So you can search on any different parameters of the system. You can see here I have two results that have tagged Dooku in them. But what about the rest? If I remove the tag specific search and I search for Dooku, you can see that other services have seen results with Dooku in it. We have also signatures with Dooku in it and alerts. If I drill down the signatures, you can see, okay, it was Dooku sample 2 that hits on Yara. If I click on it, I can actually view what is the signature, and you have an idea if that signature is good or not. And you can actually edit that signature if you see that signature is too noisy. You can click the edit signature, and you can change the parameters, and it will create you a new revision for that signature, and then you can deploy a new signature on the fly. We've added features to Yara to actually do proper scoring. So basically, if we want to identify an implant, for example, like this one, we said that the group of the signature was implant and the name was Dooku. So if you hit on that signature, it will actually tag this malware as Dooku for sure. So we added those features, and if you want to know more about our standard for our Yara rules, there's a malware standard document here while you edit the signatures, or you can access it from the help here. If I go back to my submission and to that file I was in, there's other things in that view. There's the empty results. So it doesn't mean that because the file ran on all the services, all of them actually produce results. And the empty results make sure that, yes, we ran onto that file, but we produced nothing. Therefore, there's nothing to see here. So you can actually prove that the service actually ran on that file. And because we've extracted this file out of another file, now it's just a zip, it was a simple thing, but sometimes it could be really helpful. Like if you unXOR something and extract it, you can actually download the file right here. So I can click on it, and then I'll have that Dooku.cart, and then that's it. I have the sample, so it was extracted, and I can download it. Or you can actually see, open the file viewer and actually see the raw file, the strings, hex values. So you can actually dig deep into that file. I saw the Hans West talk yesterday on Android, and I got inspired actually about this. So I have a malware that's Android, and I'll show you the power of AssemblyLine through this malware. So if I put my Android malware and actually ask my Android service to extract the dex file as a jar, you'll see the power of it. So basically, submit the malware, scroll down here, and then you see, okay, it's scored 1500. I can click on it. I extracted all the features, extracted all the features that François was using yesterday in his talk, so you can actually get to those features quickly and actually like group malware together by extracting those features. And I even added some checks based on François' talk, like this package version is suspiciously low. It's version 2, so it's rare the application will have version 2 as a version. And then if you go at the bottom of it, you can see I've extracted a file. So I took the dex file and converted it into a jar. So let's dig deep into that one. So I have a jar file now with the dex code of the Android binary. If I scroll down, I have an espresso service. What that does, it actually analyzes Java jars, and it can actually decompile the source. So if I scroll down to the end, I get this audio recorder of Java. Oops, not that, here. If I do file view, well then now I have the Java file, exact source code of the malware. And you can see it here. It does an HTTP GET with, I don't know if I can scroll this that way. Yeah, okay. So yeah, so if I scroll it, you have the bot ID and then IEMI. So basically, we've decompiled the Android binary and have the source code directly, so we can actually do analysis directly like that. Now, to go back, so you can see that our file, actually, one more. So our file scored 1,500. So that score, what we'll do, it will generate an alert in our system. So if we go to the alert page, this is the kind of view that the analyst would actually go through. Like submitting one file at a time is not efficient when you have 10 million of them. So the alert view is really where the analyst is going to spend most of his time. So in here, you can view all alerts that came in the system in descendant time base. So you can see here that's the latest alert that I have in the system. And then you can apply labels to those alerts to classify them. You can actually dig deep into the alert. So if I want to see like all the features that were generated into the last 4 days, you can click on statistics and you see, okay, I've attributed all those files to those names here, like APT28, Ghost, Dooku. So you can actually drill down all those features and actually find out which of the alerts you want to tackle now, and then you can mark them as processed. So basically, if I was to say, okay, I'll do the iBanking one because I was doing that earlier. So now here, that's the ing.apk that I was working on. I could say, okay, take ownership, and that's mine. It's been processed, it's green. No one else will actually tackle that file, and then you're done with it. So you can actually block the domains and everything. And to add those labels, you can actually add them automatically also in the system. So you see here that we do AL attrib, that's the search to actually pinpoint that malware. So we can actually take that search and then we create a workflow. So if we see that over again, I went a bit fast here. So if you go here to the manage workflow filters, you can click on here, and then you can add a workflow and say, okay, if I see that query over again, well, then this will automatically label this information, and you could say, okay, that's definitely malicious. So I could say, like, it's attributed, and it's critical, and it's malicious. The name doesn't matter. And next time this file comes in the system through an ingest, it will actually label it malicious, label it critical, and then apply the label attributed. And then people can actually focus on their job by looking at those status here. So, okay, what is malicious? Then I'll focus on that. Okay, what do I need to tackle that's critical? I can check. Okay, malicious critical is this thing that I need to process now. So that's how we go through the 150,000 alerts. We have analysts that creates automatic filter in our system, and that will go through the alert viewer to actually process those things. Okay, what else? Yes. After Consoles talk yesterday, I looked and creating a new detection for the system. So what we did is we've actually are classifying every single check that we do in the system. So if I click on malware heuristics, you can see that for Android APKs, we have different checks that we do. And I added one yesterday. Here, package version is unlikely. If you click on this and you have a check, so that's the check that we're doing, package version unlikely, and that package version is suspiciously low or suspiciously high. So basically, I've created that detection, I tagged it, gave it an ID, and now in the system, you know that I'm looking for these features. So the idea here is we have a lot of people working on a lot of different tools, but we don't know all of the features that these tools do. So in our system, what we do is we actually classify every single detection that we do, so we can actually go back and say, this is what we can do on an APK. So if you go through that list, and then you have all the tools to tell you, okay, this is all the stuff that we look for in an APK. So you have an idea what our detection capabilities are, and you could add more, or if you see one that you want to use, you could reuse it. Okay. Last but not least, APIs. You don't have to use our UI if you don't like it. And if you have other systems that can do data management and stuff like that, you might want to just use our UI to push files in and get the results back as quickly as possible, right? So all that I did in the UI right now is all through APIs. You can redo the same thing into any other system. Go through the API and actually just call them, and that's it. So anything that I do here, you can do it yourself in your own tool. That's just an API call. That brings me back to the presentation. The goal is to automate everything. So basically, you can install our Python client, AssemblyLine client, and then you can load up an IPython, just import the client, connect to the server with the simple connection, and then submit a file, and then get the full results. That's it. So you don't have to use our UI. You can use our client to just automate all your stuff. And to actually add a service, super easy. There's a base class that you need to overload. There's an init function that lets you start your service and have some parameters to init. And then there's an execute function where you receive a request, and then you process that request. Everything is in there to actually download the file. Everything's in there to actually know what's the information about that file, what type of file it is, what's the hashes. And you can actually know every service that ran before you, what tag they generated on that file. So you can actually do post-processing services that will say, okay, from all those tags, I can generate an alert based on the combination of things that we've extracted. So everything's in there. So it's really easy to start a new service. And I'll leave it to John.
I guess the one other thing to mention about what you can do with services is that, technically speaking, while the chain is processing, a service can actually add in another service. So you can actually create these really complex dynamic chains. And technically speaking, I don't think we prevent you from creating a cyclical graph. So just be advised, don't do that. It won't end well for anyone. So why are we here? It's a big question. I guess like we're recruiting, so we want you to come work for us. But really, we've been kind of hiding in the shadows for 7 years, right? We haven't had the ability to come out. Like, we come to these conferences usually, but we never really tell anyone where we work. We don't get to kind of have that interaction with the kind of the experts in the field, right? So we're kind of done hiding. It's not really fun. And we'd like to stop suffering in silence. This is not just affecting the government of Canada. This is affecting everybody, right? Like we're making it really easy for the bad people to win, right? Like this cat and mouse game where the cats just really don't like each other and the mice are just running around and taking all the cheese, and that's not really working, right? So for those of you who are students, we'll hire all of you today. Go talk to Mel. Don't quote me. If we have a running joke that if you can spell C, we'll hire you. You don't need to be able to code in it. That's preferable, but we'll start with basic literacy. I really hope this doesn't hit the media. The other thing, now I've lost my train of thought. So. Okay, so why are we here? So the better question is why open source? We've had this kind of running joke within the team for a while is that we all really want to work from home. And when you're working in a classified environment, that's really, really hard to do. So I wonder how we could actually ever work from home. Maybe if we just release the thing that we're working on, well, then we can do that. And it's actually worked. This is like our work from home laptops now. On the other hand, the government of Canada has been pretty clear in the last, let's say, 6 months about their willingness to work in the open. There was recently an open first white paper published on the Canada.ca GitHub account. I'd recommend you guys go take a look at it and put in your feedback. Like they're actually doing policy in the open now. Within CSE specifically, we don't feel that we are necessarily the leading experts on everything, right? We're pretty good at what we do, but we know there's a lot of people in the community that are also really active in this space. And we'd like to work together, right? We've specifically released the framework in this case and in a few services. We'd like to get to the point where we can release everything, but obviously there's challenges in that. So rather than us trying to go out and find out who the actual experts are in this field and, create an NDA with them and work behind the scenes and lawyers, like we'd rather just kind of release this and see who starts participating. And then once we get that participation, then those are the people we want to work with, right? The ones that can be effective and go from there. I'll just kind of close off a couple of questions that we see recently is why MIT, right? There's a big flame war going on about that. We don't want to dictate what other people do with our code. If you want to take it and put it into a commercial product and sell it, great. Like that's awesome, right? At the end of the day, if the rest of Canada gets more secure because of what we release, that's a win for us. It means we have to do less work, right? It kind of goes back to our laziness as developers. The other question we've got is why Bitbucket? Why not, right? We have some code on GitHub. You can go check out our repos there. We have some code on Bitbucket. We're trying things, right? So this isn't a choice of commercial products by any means. It's just why not? Really, though, the answer to why open source and why are we here is that would like people to stop building distributed task queues, right? Let's be honest, that's what AssemblyLine is. It takes files and moves them around. It does things. There's a lot of other products in this space now that have been released probably in the last 6 months to a year, which is a bit frustrating because we've had this for a while and we wanted to release it and it's taken us a while to go through the process. But the idea is that the people that are doing malware analysis, and then the two of us are in that camp, is that I'd rather we focus on doing malware analysis and actually building complex analytics instead of building distributed data stores. Like, as much fun as it is, it really is really fun. It's not the best use of our time. So focus on the malware. That's where we're going to make our attackers hurt. And then again, the other thing is that we can't keep this stuff secret anymore. It doesn't work, right? Like, we're losing. That's the simplest way to put it. We're very effective at keeping things out, but every day you see things happening. I'll pick on Equifax because they're the most recent ones, right? Like it's just not good enough, right? Like if I'm going to give my sensitive data to a company, like I expect them to do their jobs, right? And letting people take my data because they haven't patched in 6 months, that's not good enough. I wasn't supposed to talk about Equifax, but I did. So one of the other questions we got, and again, if you really want to have some fun later tonight, go to the CBC article and kind of reach out to the Facebook article and some of the Reddit threads and just see how much awesomeness we have to deal with when dealing with the general public. We may have forgotten to actually tell people who we wanted to work with in this case. We said we're releasing this to the public. This isn't like a replacement for your desktop AV. We're not deploying spyware to your machine. Like, we're not going to take all your files and send them to Russia. Like that's kind of, we're trying to stop that, right? So I really don't understand. Another comment we had is, like I'm never going to install CSIS spyware on my machine. I'm like, that's great because we're not CSIS, so you can install ours. It's awesome. But really, though, seriously, we're looking to partner with governments. So around the world, again, there's lots of governments that are doing the exact same things as we are. They want to keep their data in their countries as well. Small, medium, large organizations, we don't really care how big you are, as long as you can actually write Python, we're good. We actually, this summer, we were down at the first conference in Puerto Rico and met with a lot of certs that are in the same space, building similar systems. For those of you who have the ability to get into that community, I strongly recommend it. They're awesome. And then again, malware research labs, academia, InfoSec community. If you're a single person, then you just do malware on your own time. Like, we want to talk to you. Like, you might be better than everyone else out there, all the corporations. So by all means, please come and talk to us. This is just a slide for where we are. So again, Bitbucket, CSE, AssemblyLine. We have two major repos, AssemblyLine and Cart. We actually have bilingual readmes for everything. We've tried to do is make this as open as possible. And then as well, for the community right now, we are using a Google group for all of our comms between the partnerships. Please come out. We don't bite. We actually want to work with you. We're not going to report you to, something or other. We just want to help. And yeah, that's pretty much all we have. If you guys have any questions, we'll take them now. And if not, we'll be outside or after beers tonight. We're pretty open. Thank you very much.